Okay, so here in this problem we've got basically two curves, and the first part they want us to find point A. It doesn't say, but it sure looks like it's a vertex for both of these, and it also looks like it's an x-intercept. It's only worth 1 point, so it should be pretty easy to do, so we're going to try to make this as straightforward as possible. In this case, if it's an x-intercept, well, we know that y has to equal 0. So let's plug in a 0 and then find out what this is going to be. Well, we'll find out that x is going to be 1/2. Now, if this is where the two graphs intersect, well, then what's going to happen is when I plug in a 1/2 into the other one, it also should equal 0, because then they'll be sharing the same point. So let's try that. What we're going to do is we're going to take this function over here, replace the x with a 1/2, and then see if it equals 0. And when we do, 1 minus 1 does equal 0, and so both functions have the same point. And so that means that a has got to be 1/2 0. You can solve this by making them equal to each other, but it's a rabbit hole and it'll take you forever. It's not worth it. So anyway, next part is to find the area between the two curves and make both equal to y, and then we're going to subtract the rules for each one. Well, the one already is equal to y, that's good, and so then let's take the other, and it's y squared is equal to 1 minus 2x. Well, if we square root both sides, we're going to find out that y is equal to the square root of 1 minus 2x. Technically, it should be plus or minus the square root of 1 minus 2x, but you'll notice that the part that we're dealing with is only the positive part. So we don't got to worry about the minus part. All we got to worry about is the positive part. So we've got to take the top away from the bottom, and it just looks like this. And we can use the chain rule because both of these are linear inside the parentheses. So there's no real reason to go ahead and square the second one. Unless you want to, you could do that too. But anyway, when I do this, I go to the chain rule. The -2, the reciprocal of that on the inside is going to be negative 1/2. And then I raise the 1/2 to 1, so it's going to be 2/3. I do the same thing here for the next one, and I find out that this is going to raise up to a 3, so it's times 1/3. All I got to do now is simplify all my fractions and my parentheses, keep everything straight. And I'm going to end up with this as my integral function. I'm going to put a 0.5 and a 0 in there, and then I'm going to subtract them, and that'll give me the area between the two curves. And I've just got to be careful with parentheses when I'm doing this. If I write it down correctly, well, then when I enter in the calculator, if I enter it in the same way, then it should be fine. Anyway, what I'm going to find out is for the first one, it ends up being 0, and the second one, it's negative 1/6. When I subtract them, I get 1/6. So that's the area between the two curves. All right, hope that helped. Thanks for watching.